Betelgeuse, the massive red supergiant star located in the Orion constellation, has been sending alarming signals across space, captivating astronomers and the general public alike. Recently, scientists have made disturbing discoveries about this colossal celestial object, using the James Webb Space Telescope to unravel its mysteries. Renowned astrophysicist Brian Cox has issued a stark warning, with a key question on everyone's mind. Could we be witnessing the onset of a cataclysmic event, an explosion that will forever change the night sky? Let's dive into this cosmic spectacle. Stars are born, live, and die in dramatic fashion, and one star in particular has captured both the scientific community's attention and public concern: Betelgeuse. This red supergiant, one of the brightest stars in the night sky, is not only a massive object but also an ancient one. Its vast size and changing luminosity have been fascinating astronomers for centuries. But recent developments have elevated interest in Betelgeuse, hinting that we might be on the verge of witnessing something truly spectacular. Betelgeuse is an absolute cosmic giant, approximately 1,000 times larger than our Sun. If it were to replace our Sun, its surface would stretch all the way to the orbit of Jupiter. This immense size is a key indicator of its stage in the stellar life cycle. Having exhausted the hydrogen in its core, Betelgeuse is now transitioning through its final phase. As a red supergiant, it is cooling and expanding, marking the end of its life as it begins to burn through helium. Though Betelgeuse is relatively young at about 8 to 8.5 million years old, compared to the Sun's 4.6 billion years, it is ancient by cosmic standards. Over the course of millions of years, Betelgeuse has undergone significant changes, evolving from a hot blue star into the red supergiant it is today. The red hue of the star comes from its cooler surface temperature, around 3,500 Kelvin, compared to the Sun's 5,500 Kelvin. This lower temperature causes Betelgeuse to emit light at redder wavelengths, providing clues about its physical condition and internal processes. One of the most intriguing aspects of Betelgeuse is its variability. It is classified as a semi-regular variable star, meaning its brightness fluctuates over time in cycles, both short-term, around 400 days, and long-term, approximately 5 years. This rhythmic dimming and brightening has intrigued astronomers for years. In fact, these cycles were first noted by Sir John Herschel in the 19th century. What sets Betelgeuse apart from other stars with similar behavior is its irregularity. It sometimes deviates from these patterns, hinting at complex and poorly understood phenomena occurring inside its massive structure. However, the most recent and startling change came in late 2019, when Betelgeuse began to dim at an alarming rate. The star, once one of the brightest in the sky, began to lose light at a rate of 0.01 magnitudes per day. By February 2020, it was at its dimmest, prompting concern among astronomers. Normally visible even in areas with heavy light pollution, Betelgeuse became faint to the point that casual observers could notice the change. The delay in our perception of the star's behavior complicates the issue. Light from Betelgeuse takes about 700 years to reach Earth, so when we observe the star, we are actually seeing it as it was in the past, not as it is now. This time lag makes it difficult to track rapid changes in the star's behavior, and has left astronomers with many unanswered questions. A team of researchers, including Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics, closely monitored Betelgeuse during its recent dimming event. Using the Hubble Space Telescope, they investigated the changes in the star's outer layers, revealing that material was being ejected from Betelgeuse's surface at speeds of around 200,000 miles per hour. This material formed a dense cloud of dust that caused the star to appear fainter over the course of 3 months. Betelgeuse's mass loss during this event was much greater than expected. While all stars gradually lose mass over time, Betelgeuse's rate of mass loss during this period was notably faster than the Sun's. The cause of this rapid mass loss remains uncertain, but some scientists have speculated that it could be a precursor to a supernova explosion. Such an explosion would be a catastrophic event, possibly signaling the end of Betelgeuse's life as a red supergiant. This dramatic event has sparked debates among astronomers about whether it could be a sign that Betelgeuse is preparing for a supernova. While it's impossible to predict the exact timing of such an explosion, The changes in the star's behavior suggest that it is nearing the end of its life cycle, and the possibility of a supernova remains a topic of great interest and concern. Rephrase it. ChatGPT said. ChatGPT. Merging heavier elements like helium through a series of atomic reactions generates immense energy, which counters the force of gravity and supports the star, regardless of its size and energy output. Betelgeuse, for instance, is approaching the final stages of its life. Stars like Betelgeuse spend most of their lifetimes in the main sequence phase before expanding into red giants and then red supergiants. The lifespan of a star largely depends on its mass, with more massive stars burning their fuel faster and, consequently, having shorter lifespans. Betelgeuse is estimated to be relatively young, around 8 to 8.5 million years old in its current phase. Despite its youth, Betelgeuse plays a significant role in astronomical studies. Observing it provides valuable insights into the evolution of massive stars and the processes that govern their formation, development, and eventual demise. Betelgeuse's transition from a hot blue star to its current red supergiant phase exemplifies the dynamic nature of stellar evolution. Stars like Betelgeuse form from vast clouds of gas and dust and undergo dramatic changes over millions of years, driven by the interplay of gravitational forces, nuclear fusion, and radiation pressure. The red appearance of Betelgeuse, caused by its cooler surface temperature compared to younger stars, makes it stand out in the night sky. While stars like our Sun have surface temperatures around 5,500 Kelvin, Betelgeuse's surface temperature is much cooler, around 3,500 Kelvin. This lower temperature results in the star emitting primarily red light. Historically, astronomers have documented changes in Betelgeuse's color over time, with early records indicating a yellowish hue, which later shifted to red by the 9th century, sparking curiosity among modern scientists. Betelgeuse is also known for its variability in brightness. Like many red supergiants, it undergoes fluctuations in luminosity. These variations can range from minor changes to more significant events, such as the dramatic dimming observed between late 2019 and early 2020. This event, known as the Great Dimming, attracted widespread attention from astronomers due to the unexpected drop in brightness, which saw Betelgeuse decrease to a fraction of its usual luminosity. This sudden fading led to various hypotheses about its cause and possible implications for future cosmic events. Early theories suggested that the dimming might be due to a cloud of dust or ejected material obscuring Betelgeuse's surface, diminishing its brightness as observed from Earth. Subsequent investigations revealed that Betelgeuse had undergone a substantial eruption, ejecting material at high velocities into space, forming a dense dust cloud that temporarily blocked its light. Over time, this material dispersed, allowing the star's luminosity to gradually return to normal levels. The data collected during this event provided astronomers with valuable insights into the physical processes occurring within Betelgeuse and similar red supergiants. These observations have helped refine our understanding of how massive stars evolve and interact with their surroundings, shedding light on the complex dynamics governing stellar development. In addition to its variability in brightness, Betelgeuse has also exhibited changes in its spectral properties throughout its life cycle. Spectroscopic studies have revealed fluctuations in the star's chemical composition and environmental conditions, offering clues about its internal structure and ongoing nuclear fusion processes. Advancements in astronomical technology, such as the Hubble Space Telescope and ground-based observatories equipped with adaptive optics, have allowed astronomers to study Betelgeuse in unprecedented detail. These tools have provided high-resolution images and spectra of the star's surface and surrounding environment, uncovering intricate details about its structure and evolutionary timeline. The study of Betelgeuse and other red supergiants is essential for advancing our understanding of stellar evolution and the broader processes that shape the universe. By observing and analyzing these massive stars, astronomers gain insights into the formation of elements, the assembly of galaxies, and the fate of stars at the end of their life cycles. Looking ahead, astronomers will continue to monitor Betelgeuse and other red supergiants for further developments that could offer new insights into cosmic evolution and the forces governing the universe. These observations are crucial for refining existing models of stellar evolution and predicting the behavior of stars under different conditions. As our understanding of Betelgeuse and other massive stars deepens, so too does our appreciation for the vastness and complexity of the cosmos. Each new discovery brings us closer to unraveling the mysteries of stars, galaxies, and the fundamental forces that shape the universe. In summary, Betelgeuse is more than just a distant star in the night sky. It is a symbol of discovery and exploration, inviting us to delve deeper into the mysteries of the cosmos. From ancient observations to modern breakthroughs, Betelgeuse continues to captivate and inspire astronomers, offering a glimpse into the majestic processes that shape our existence and our place in the universe. As we continue to study Betelgeuse and other celestial phenomena, we embark on a journey of scientific discovery that promises to reveal the secrets of stars, galaxies, and the very nature of the universe itself. The sudden dimming of Betelgeuse, located about 725 light-years from Earth, has sparked significant interest among astronomers. Such an event would be noticeable from our planet and offers a rare chance to observe a cosmic explosion up close. However, the key question remains: what does this dimming mean for Betelgeuse's future? Is it a sign of an inevitable supernova, or is it simply a temporary fluctuation in the star's long and complex life? Several hypotheses have been proposed to explain this rapid change. One popular theory suggests that this dimming is a precursor to the star's impending explosion, as Betelgeuse nears the end of its life cycle. Another theory proposes that dust, possibly shed by the star itself, could be obscuring our view of it. Red supergiants like Betelgeuse are known to shed material, which could form a dust cloud thick enough to block out some of the star's light. A third theory explores how changes in the star's photosphere, its outer layer, could be influencing its brightness. This puzzle was tackled using a variety of observational methods. Spectroscopic studies revealed that Betelgeuse's temperature had decreased, suggesting that a large dark spot had formed on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supports this idea, indicating significant changes in the star's outer layers. Ultimately, the Hubble Space Telescope provided crucial insights into this surprising event. Its observations revealed that the dimming of Betelgeuse was likely caused by a massive amount of hot matter being expelled into space. This material formed a dust cloud that blocked out part of the star's surface, reducing the amount of light reaching Earth. The dust cloud was thought to consist of hot plasma that originated from a large convection cell on the star's surface. As this plasma moved through Betelgeuse's hot atmosphere and cooled, it formed dust grains that obscured about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic data, which began in January 2019, played a vital role in understanding the events leading up to Betelgeuse's dimming. These studies detected dense, hot material traveling through the star's atmosphere in the months prior to the dimming. Several ground-based telescopes also observed the star's brightness decline in December 2019, particularly in its southern hemisphere. Initially, the expelled material was brighter than the star itself, but as it moved outward and cooled, it became a shadow that contributed to the sudden dimming. This eruption was extraordinary, drawing attention from astronomers worldwide. Betelgeuse expelled around 400 billion times the mass typically ejected in a coronal mass ejection, with a material thought to be several times the mass of the Moon. This outburst was significant in the context of stellar explosions. Betelgeuse, a star that has fascinated astronomers for years, continues to captivate us with its unusual behavior and dramatic changes. Located in the Orion constellation about 725 light-years away, Betelgeuse is a red supergiant, a type of star nearing the end of its life cycle. Unlike stable stars like our Sun, which maintain a relatively constant brightness and size for billions of years, red supergiants like Betelgeuse are constantly undergoing transitions. This variability is primarily due to their immense size and the complex processes occurring inside them. One of the most notable features of Betelgeuse is its massive size. While the Sun has a diameter of about 1.4 million kilometers, Betelgeuse is about 1,000 times larger, with a diameter extending beyond Jupiter's orbit. This colossal size not only affects its appearance but also plays a crucial role in its life cycle and behavior. As a red supergiant, Betelgeuse has exhausted the hydrogen fuel in its core and is now undergoing other nuclear fusion processes, nearing the final stages of its stellar evolution.